This is number 4 on page 380, and I'm given two roots, 1 and 2 minus 3i, to an equation. I'm supposed to write a third degree equation that has these roots. So I know that if 2 minus 3i is a root, that its conjugate 2 plus 3i will always also be a root, because complex numbers always show up in conjugate pairs as roots. So then I can write a third degree polynomial. So x minus the first factor, the first root, times x minus the second root, times x minus the 2 plus 3i equals 0. Now, I can simplify these two and FOIL them all out, but I'm instead going to use a shortcut. I know that when I multiply together two factors, that I will always get x squared minus the sum of the factors, r1 plus r2 times x, plus the product of the factors, r1 times r2 equals 0. So knowing that, I'm just going to find the sum of 2 minus 3i plus 2 plus 3i, and you could pretty much just do that by looking. The 3i's will cancel, and the sum is 4. And the product of the two is going to be 2 minus 3i times 2 plus 3i. So that's going to be 4 plus 6i minus 6i minus 9i squared. So that's 4 minus negative 9, or 4 plus 9, or 13. So I know that when I FOIL those together and eliminate everything, I'm going to have x squared minus the sum of the roots, so minus 4 times x, plus 13. Okay, now, really quick and easy way is look at these two. The sum of the two is 4. The product of the two is always going to be, when you're dealing with complex conjugates, 2 squared plus 3 squared. So 2 squared is 4, plus 3 squared is 9. It's always going to be 4 plus 9. So that's a real short way to get to this. Okay, now can't forget to multiply it by x minus 1. So I get x to the third minus 4x squared minus 13 minus 1x squared plus 4x. Oh, sorry, this was, when I multiplied that was 13x. Okay, sorry, minus x squared plus 4x, and then minus 13 is equal to 0. So my final answer, my final equation will be x to the third minus 5x squared plus 17x minus 13 equals 0. So that's my answer.